Hello friends, welcome back once again in the next lecture of the Swift series. And in today's lecture we will discuss about concurrency, parallelism, and why we need the concurrency and how we can achieve the concurrency. So the different topics we will cover in this lecture. So the first of all, what is the concurrency? So the dictionary meaning of the concurrency is the fact of two or more events or circumstances happening or existing at the same time. So suppose here is a person and attending two call at the same time, so it's the scenario of the concurrency. So by definition of the concurrency is the execution of the multiple instruction sequences at the same time. Suppose here task 1, task 2, task 3 and task 1 again. So execution of task in a single core environment. Here we are using suppose a single processor and executing multiple tasks at the single processor. So tasks are context switched between one another. So with the help of the context switch we are implementing concurrency. So concurrency means executing multiple tasks at the same time but not necessarily simultaneously. So what is the meaning of it? So two tasks can start, run and complete in overlapping time period. So what is the meaning of it? That task 2 can start even before task 1 gets completed. So here is a example of the concurrency. So here is a person and he is doing two jobs at the same time. He is eating and singing at the same time, but when he is he stops singing, but when he is singing he stops eating. So both work, he is working concurrently but not simultaneously. So here the person is doing two jobs concurrently. He is doing two jobs at the same time, but he is switching between eating and singing. So it's the concurrency. So next is the parallelism. So the dictionary meaning of the parallelism is that the state of being parallel or of corresponding in some way. So here is the example of the parallelism. A lady is performing multiple tasks at the same time. Suppose he is attending a call and same time he is working on the computer and same time he is taking a tea. So multiple tasks she is performing at the same time. So it's the parallelism. So the definition of the parallelism is the use of multiple processing element simultaneously for solving any problem. So here we use multiple processing element simultaneously for solving any problem. So parallelism means performing two or more tasks simultaneously. Parallel computing in computer science refers to the process of performing multiple calculations simultaneously. So here two tasks are being performed simultaneously over the same time period. So it's the parallelism. So here is the another example of the parallelism. Suppose someone is performing two tasks at the same time. He is cooking and speaking at the same time without switching with each other. So cooking will not any effect on the speaking. So someone can speak at the same time, she or he can cook anything. So cooking and speaking is the example of the parallelism. Here we will discuss what is the differences between the concurrency and parallelism. So concurrency versus parallelism. So concurrency and parallelism refer to computer architecture which focus on how our tasks or computation are performed. So concurrency and parallelism are showing the computer architecture how task and calculation are performed. So when we talk about in single core environment, concurrency happens with task executing over same time period via context switching. At a particular time period, only a single task gets executed. So when we talk about the single core environment, so it means that we are doing multiple job at the single processor. So it's the example of the multi-core environment is the parallelism. So concurrency can be achieved via parallelism in which multiple tasks are executed simultaneously. So when we talk about multi-core environment, so it means that we are doing jobs with multiple processor without context switching. So it's suppose this is the job 1 and this is job 2. So it can be more than 2. So here we are doing multiple jobs with multiple processors. So parallel code means multiple pieces of code run simultaneously. For example, a computer with a 4-core processor can run 4 pieces of code at the same time. So here parallel code means multiple pieces of code run simultaneously. For example, a computer with a 4-core processor can run 4 pieces of code at the same time, with each core carrying out one of the tasks. So here is another example of the concurrency. Here 2 queues and single coffee machine, and the example of the parallelism is that here 2 coffee machine and here 2 queues. So next is how concurrency is achieved. So the time slicing and context switching. So we can achieve the concurrency with time slicing and context switching. So we have the another options to achieve the concurrency, suppose interruptions, scheduling algorithms, and time quantum. So many more we can use, but the two very important we use for achieving the concurrency is the time slicing and context switching. So we will discuss here. So what is the time slicing? So a time slicing is a unit of time given to each process in a operating system. So when any job is executing, so each process is scheduler grant a time, so it's called a time slicing. So a time slicing is a unit of time given to each process in an operating system. So when job is executing, so each process has a time, so it's called a time slicing. So time slicing is the amount of time that a process is given to execute before it is preempted. So preempted is nothing is pushing in execution, and another process is given a chance to execute. So in time slicing, one job is resumed and another job executed. So when job is pushing and another job is executing, so is called a preempted. So time slicing is nothing is a amount of time that a process is given to execute before is preempted. The task of time slicing is divided in available CPU time into available runtime, thus make the CPU available for thread. So context switching refers to a technique method used by OS to switch processes from a given state to another one for the execution of its functions using the CPU present in the system. So context switching helps in sharing a single CPU among all processes so as to complete the execution and store the status of the system tasks. Here is the example of the context switching how actually work. So here is the two tasks, task X and task Y. So when task X is executing, CPU switch into the task Y, and when task Y is executing, so again switch into the task X. So task X and Y are performed with help of the switching. CPU switch multiple times from one job to another job. So context switching how actually work. So suppose here is the CPU, and suppose here we are taking multiple processes. Suppose here I am taking process 1, process 2 and process 3. So suppose we are doing multiple jobs. So suppose first process 1 is doing any job. Suppose CPU is working on the process 1. So at the same time process 2 is want to execute and send request to CPU. So when P2 send request for execute, so scheduler save the address of the P1. Suppose here is P1. So suppose here is a PCB process control block. So P1 address is store here. Suppose here is the address 001. So P1 address is store here. P1 again want to execute. So P1 will execute from the same address. So in PCB address of the P1 is stored already, and P1 will execute from the same address. So how much work of the P1 is completed, so it will not waste. So P1 will execute from the same address. So suppose 30% of the P1 is completed before preempted. So when again P1 will execute. So P1 will execute after the 30%. So the 70% of the P1 will be execute when again P1 will be execute. Switching of CPU to another process means saving the state of process and loading saved state for new process. So next is, what is process? So process is a program being executed in the operating system. A process is something that is currently under execution. So an active program can be called in process. For example, when you want to search something on the web, then you start a browser. So this can be a process. So process is nothing when you are doing something on the internet or you doing any job. So suppose another example of the process is that when you start a music player and listen some cool music to your choice, so it's called a process. So process is a task you are doing on any system. So again, what is the thread? So process can be further divided into independent units known as thread. So thread is like a small lightweight process within a process. So thread is a sequence of instructions that can be executed by a runtime. Each process has at least one thread. So suppose here is a process, and here in a single process can have multiple threads. So type of thread, mainly we use two type of the threads, main thread and background threads. So what is the main thread? So main thread is where user perform the interaction. So when user performing any action on the application, suppose when clicking on any button, scrolling any table view, so all these operations are performed in a main thread. So if we call the background thread function on the main thread, it will freeze the UI. So it's a very important when we performing the background thread operations into the main thread, so it thread will freeze the UI user interaction and user won't be able to perform any interaction with the app. That will make him think about that app is freezed. So the background operations, like when we are getting something from the server or we downloading something from the internet, so all the background operations we should not be performed in the main thread. We should always apply into the background thread, because the background thread operations always freeze the UI and user cannot interact with the application. So actually, what is the background thread operations? So where you perform your heavy operations like API calls, downloading of an image from server. So all these type of operations we always perform in background thread. So again, question is that what is the multi-thread application? So we could say that application is multi-threaded since it uses more than one thread. So when application use more than one thread, so it's called a multi-thread application. So what is use of the multi-thread? So multi-threading is a pattern to increase the performance of an application, and scheduling work on multiple threads, more work can be performed in parallel. So when we are doing multiple job in the same system, so we are doing multi-threading. So when we are doing multiple job in the system, suppose when we are doing something on the system and at the same time we are listening some music from the system, so it's the example of the multi-threading. So how can we achieve multi-threading? So your device has multiple CPU cores. To make use of these cores, you will need to use multiple threads. So your device has multiple CPU cores. To make use of these cores, you need to use of the multiple threads. So in today's world, we have many devices are performing multi-threading, because mostly all systems have dual core or multiple processors. So in concurrency and parallelism, we have already discussed the example of the multi-threading, and with the help of the concurrency and parallelism we can achieve multi-threading. So again is that why do we need concurrency? So what is the need of the concurrency? We have understood that what is the concurrency already. So why we need concurrency? So almost all devices we used in iOS have multi-core processors and that allow developer to execute multiple tasks in parallel. So every device and every system we can perform multiple jobs. So suppose we can listen music and we can doing any another job. Suppose we can at the same time we can programming something and can listen music. So all these are the example of the concurrency and parallelism, because these are allow developers to execute multiple jobs in parallel. So to enable run multiple application at the same time, it enables that resources are unused by one application that can be used for another application. So with the help of the concurrency, we can utilize the resources more efficiently, because it enables that resources are unused by one application can be used for another application. So if we do not use concurrency, so we cannot perform multiple operation at the same time. So before completion of the one task, we cannot start the another task. So I hope this video is helpful. So if you like this video, please like, share and subscribe the channel. Thanks for the watching.